Okay, I'm gonna show you a calculator I made in Minecraft. I finished it a few months ago, or I stopped working on it a few months ago, so I don't remember everything that happened that I did. And it didn't actually work exactly the way I wanted. The issue is all the parts, when I tested them, worked fine individually, but when I put them together, uh, I get differing behavior every time I test it. I think what happens is that the game starts to lag when everything is working together, and the lag will make maybe one component out of like 10 identical components behave strangely every once in a while. And that throws off the calculation. So my calculator actually does not work, I think, because of the lag. Although it's hard to test everything when you get different answers from the same input. Anyway, I wanted to make a calculator that could add, subtract, and multiply. The division is very complicated, and I decided not to do it. I think I made a design that would have worked, but I calculated it would have taken like an hour with this setup to divide one number, because division is complicated, and it would have required twice the number of bits to handle decimals. That's the fastest way I could think of. It's the Newton method of finding roots. But anyway, you start here. At this point, it just converts a 3-digit decimal number into binary. I could have made a few extra. I think it wouldn't have been very complicated to start multiplying after that. But anyway, it starts here. You click one of these buttons, and it'll feed into here and store the single-digit decimal in 4-bit binary. And this one here just shows that it has data. It lights up whenever you press a button. And so there's so this doesn't actually show that it just registers that you've entered a button, so the circuit knows when to stop. And these are three different 4-bit numbers converting the 3-digit decimal numbers into binary. And then it will feed over here into my multiplier. My multiplier has two pieces. This piece here is one number, and this piece there is another number. And it basically multiplies the same way you multiply by hand with decimal. You copy, or you multiply one digit at a time, and then you add it together. Since we're working with binary, multiplication either means you multiply by 0 or by 1. So it just ignores it if it's 0, or copies it if it's 1. So what happens is every clock cycle, oh, there's my clock, by the way. I used a series of, what are they called? T flip-flops, I think, to make my clock. I'll turn it on in a few minutes. Anyway, so after each clock cycle, this one shifts one digit to the right, and this one shifts one digit to the left. And then the last digit here will multiply. You'll multiply this last digit here by all the rest of this. What that does is it means well, if you work it out, you'll see it'll work. It's hard to explain verbally, but that ends up adding it. And then so it'll multiply this thing by the last digit here, and this is constantly being this number is constantly being shifted to the right, and this one's being shifted to the left. And this circuit here automatically sets this number to be equal to 1, 10, or 100, so that it can convert these digits, and these digits go into here. So it multiplies it by 100 for the hundredths place, by 10 for the tens place, and 1 for the ones place. And then I have some circuits here over there to switch to organize everything so it lines up right. And then once it's multiplied, it feeds in here, and then goes into here, which this is the input for my ripple carry adder. And here's the buses for it, and here are the bits for the ripple carry adder. it has 11 bits, so 11 of these, and then the data comes back here. And I feed off the data, and it saves here. These are some memory bits. These are memory bits too. Anyway, so it doesn't, the whole thing together doesn't work because of the lag, like I said, but the ripple carry adder works just fine as I remember, so I've fed 1 and 2 and 3 into it manually. And I'm going to flip it on, and you can see the thing start working. Ordinarily, I would feed numbers in through here, and then get saved here, and when it was all saved there, then I'd turn it on and it would go. But like I said, I get different results every single time I test this thing, which makes me think that it's the lag rather than my design. Anyway, so I'll click convert now. It'll start the clock. So the clock should be on 1 right now, but it takes a second to update. Now that's 2. Okay, so let's see what it should take. Oh, the bits are moving good. Or did it clear it? Oh. Well, anyway, I think I actually told it to clear at the very beginning, which means that the bits I fit in at the beginning aren't going to do anything. I'm going to feed them. Okay, let's do 1 and 2 and 3. Actually, I will wait for the clock to move these. I hope it'll move. There's been an update since I last made this, so it might not move anymore. It's a very long clock cycle, actually. Oh good, it's moved. Okay, so there's 1 and 2. I'll add 3 now, so I'll add 1, 2, and 3. So as I recall, this part worked just fine. So it should add up to 6, which is 2 and 4. So after a few minutes, this should be lit up, and that should be lit up after the next clock cycle. I guess I will cut out some of the video. There was a village here. I destroyed it to make my calculator. So yeah, it's a bit disappointing. When I got to the point where I realized that I was getting different errors every single time I ran it with the same input, I concluded that the lag was the issue and gave up. I guess I could remake the whole thing from scratch with a slower clock cycle, and hopefully the lag wouldn't affect it so much in that case. But well, so it's added 1 and 2, so that's 3, and then it's going to add 3 and 3 together. That should make 6, so we'll see what happens. Anyway, these bits here only work with this clock cycle. If the clock is too slow, it won't work. So I need to rebuild basically the whole thing from scratch if I'm going to use a lower clock cycle, and I didn't want to do that. It took a long time. Oh, there's 6, so my ripple carry adder works. Okay, so I'll quit the video then.